Today, we are going to discuss the software security problem known as broken authentication. First, we will examine what broken authentication is. Then, we will analyze how authentication can be broken. Due to its intricacies and its significance to broken authentication, we will further analyze man-in-the-middle attacks. Then, we will discuss mitigation efforts that an organization can implement to help protect against broken authentication. These mitigation efforts deal with both policy and technology. The most important mitigation effort is multi-factor authentication, so we will examine that in some greater detail. What is broken authentication? It is important to note that broken authentication deals with any security flaw related to an error in the implementation of authentication and session management of a web application. Broken authentication at the surface appears to just be terminology regarding an account being hacked. However, upon further examination, there are many ways that authentication can be broken, which we will go over. It is not simply a hacker cracking a password, although that is one way that broken authentication can occur. Authentication can be broken in several ways. First, phishing attempts are a popular way to break authentication. There are two popular phishing attempts that attackers use to break authentication. First, administrator accounts specifically may be targeted. This is due to the fact that being able to log in as these accounts will allow an attacker to more easily bring down a web application or inflict damage to the organization. Second, attackers may use a widespread phishing campaign which targets all email addresses in the entire organization. This is seen more commonly in organizations that are smaller, since they will be much less likely to have an automated spam filter in place to prevent the emails from reaching everyone in the organization. Credential stuffing is another popular way to break authentication. This is when an attacker uses credentials that were compromised from one site on a different site. Duplicate passwords actually result in a stunning figure in that 73% of online accounts can gain access to authorized accounts using duplicate passwords. A third way that authentication can be broken is with the technique known as password spraying. Password spraying is sort of like a brute force attack, but instead of using different passwords on the same account, the same passwords are used on different accounts. This allows attackers to try to compromise accounts with weak passwords without locking the accounts out, lowering the risk of the attack being noticed by someone. Finally, man-in-the-middle attacks are a popular and intricate way in which authentication can be broken. There are several variations of man-in-the-middle attacks, including session hijacking and decrypting data with an illegitimate certificate while spoofing as the legitimate web application. Due to the intricacies of man-in-the-middle attacks, it is important to further analyze this attack vector. Session hijacking is when an attacker steals a session from a valid user, thereby impersonating the user. This can be done in a few ways. One way is by injecting session numbers into a URL if session IDs are exposed in the web application's URL. An attacker can notice a pattern in the way session IDs are doled out to users and try to compromise the next valid session ID based on using the pattern. Attackers can also inject random session numbers into the URL in order to attempt to generate a valid session. Another common way for session hijacking to be executed is when there is not a timeout period for inactive sessions. Users may walk away from their computers and stay logged on. If the web application does not have any timeouts, an attacker can hijack this inactive session. In addition to hijacking comes the possibility of spoofing. With this method, an attacker can trick the user into downloading what appears to be a valid, legitimate certificate from the website. Unknown to the user, their data is now being decrypted and can be observed by the man-in-the-middle attacker. There are fortunately some mitigation efforts, some relatively easy to implement, in order to lower the chances of authentication being broken. The first efforts to review are policy related. It is important that organizations enforce password complexity requirements. Specifically, it is a good practice to require passwords that are at least 8 characters long and contain at least 1 capital letter, 1 lowercase letter, 1 number, and 1 special character, such as the @ symbol. Going along with complex passwords, organizations should also enforce that passwords be changed cyclically and not allow users to have the same passwords forever. Some web applications may have hard-coded credentials or static passwords for ease of use, especially when multiple people are trading off on using the application, but this should be avoided at all costs. There are also mitigation efforts specific to technology to help prevent broken authentication from occurring. Error messages should be generic. When logging into a system with incorrect credentials, the error message should not specify whether the username or password specifically are incorrect, because this will give attackers hints on which part of the credentials are right and wrong. There should be a mechanism in place that temporarily disables accounts automatically after so many incorrect login attempts. Timeouts should be implemented for sessions where the user goes inactive so that their session cannot be hijacked during this time. Finally, there are specific technical components that can be implemented to help prevent the chances of broken authentication occurring. Specifically, SSL certificates can be put in place to encrypt data. VPNs can ensure that users must connect to a secure network before accessing the web application. And web application firewalls can be installed to allow only known traffic to enter the web application. Arguably, the most important mitigation effort is multi-factor authentication. When this is enabled for an account, the user must successfully authenticate their login attempt from another device, such as entering a code texted to his or her cell phone. Even if an attacker compromises a user's password, the user would still be relatively safe if multi-factor authentication is enabled for the account. The attacker would need to additionally gain physical access to the user's multi-factor authentication device in order to log in as him or her. In conclusion, the express findings indicate that there is an utmost importance for developers and organizations to have knowledge on broken authentication and how to help prevent it from happening. Time and time again, the Open Web Application Security Project rates broken authentication as the second most critical web application security vulnerability, so this stresses even more that organizations should ensure their development teams know how to protect against this vulnerability. There are some relatively simple and straightforward mitigation efforts that companies should implement in their web applications. The cost of mitigation should be weighed against the risks of the organization if a broken authentication attack occurred. While upper management may not want to spend money on mitigation efforts, in the long run they can financially pay off.